Hello everyone, section 3.4, real zeros of polynomial functions. We're going to start with Descartes' rule of signs. Descartes' rule of signs is going to tell us how many positive real zeros there are, how many negative real zeros there are. It's fairly simple to do. When we take a look at the original function f of x, we look for the number of changes in signs. Positive to negative, that's one change. Negative to positive, that's a second change. Positive back to negative, that's a third change. Okay, so 3 changes means that there are 3 or 1 positive real zero. Now, why is it 3 or 1? There are 3 changes, that's easy. Why is it or 1? Well, it's possible that there's 1 positive real zero and 2 imaginary zeros. Imaginary or complex zeros always come in pairs, plus or minus I, because to get them you're going to be doing square root of a negative number, and whenever you're doing square root you are introducing a positive and a negative solution. So complex imaginary numbers always come in pairs. So it's possible that there's 1 positive real zero and 2 complex or imaginary zeros. It's possible that there are 3 positive real zeros. All 3 of them are real. To find how many negative real zeros there are, we're going to put in f of negative x. So you plug negative x into the x's in the original function, and what that does is that's going to change the signs on all the odd powers. Notice the even power, that's going to become back to an x against this stays negative 5x, which is what it was originally. The odd powers, that's going to become a negative x cubed. So negative 3x cubed is opposite of what it was before. And same here, this is the first power. So this becomes negative 6x, which is opposite of what it was. Negative, 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 negative. There are no changes. So if there's no changes, means that there are no negative real zeros. Now how does that help us? So now when we go to make our list of possible real zeros using the P's and Q's that you learned in Algebra 2 and Trig and Pre-Calculus that we're going to revisit again here in this unit, we would be able to eliminate all the possible negative real zeros. We wouldn't even look at them because there aren't any negative real zeros. Okay. Example 1, Part A. According to Descartes' rule of signs, how many positive and negative real zeros are there? So let's look for the number changes. Positive, positive, negative, that's 1 change, and all the rest are negatives. So there is 1 change, which means that there is 1 positive real zero. And here we've got f of negative x is going to give us, now again, the even powers are not going to change, the odd powers are going to change. So we're going to have 2x to the 4th minus 7x cubed minus 4x squared plus 27x minus 18. 1, 2, 3 changes. Means that we have 3 or 1 negative real zeros. So there's 1 positive and 3 or 1 negative real zeros. Part B. Do the same thing again. Here we have positive, negative, positive. That's 2 changes. That means that there are 2 or 0 positive real zeros. And take a look at f of negative x. The odd changes, so that becomes negative x cubed plus x plus 1. One change. Therefore, we have 1 negative real 0. Okay, rational zero test. This is your P's and Q's. Okay, and just to remind you, the P's come from the all the factors of your constant term at the end. The Q's are the factors of the lead coefficient term. Okay, and then you take all the possible combinations of all the different factors of P divided by all the different factors of Q, and then you're going to have your list of all the possible real zeros. You'll see that in practice. Let's take a look at example 2. So P equals, so factors of 6, plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. Factors of Q. Well, lead coefficient is 1, so it's just plus or minus 1. So the P over Q is really just the P values. Plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. Okay, let's see if we can narrow down this list. Possibly, might not be able to, but it's worth looking at Descartes' rule of signs to see if we can narrow down the list. All right, number of changes. 1, 2, 3. 3 changes, so 3 or 1 positive real 0. F of negative x, x to the 4th plus x cubed plus x squared plus 3x minus 6. Had that been a plus 6, then we would have been golden. We would have had no negatives, but we only have one negative real 0 to look for. Now, usually, not always, but usually if I see only one negative, that's the one I'm going to look for first, because once I find it, I'm going to stop looking. So now we go to synthetic division. We go 1, negative 1, 1, negative 3, negative 6, and let's try negative 1. 1, negative 1, negative 2, 2, 3, negative 3, negative 6, 6, 0, and I got a 0 on the first try. That's lucky, it's great, it's awesome. But because I know that there's only one negative real 0 and I just found it, I am not going to even look at negative 2, negative 3, or negative 6. I'm taking those off the list. I'm not even going to check them. Okay? So I just need to find one positive one, because right now I was x to the 4th. This is now x cubed. And again, I'm going to go down to this. I'm not going to go back to the original. I'm going to go to this. I'm going to find one positive one. Once I find that one positive one, then I'm going to go to the quadratic formula or factoring, because I'm going to be down to quadratic. Okay. Let's check positive 1. I don't think positive 1 works, but let's check it. Bring down the 1. 1, negative 1, negative 1, 2, 2, negative 4. Didn't work. That's okay. Let's I'm going to go off to the side over here. We'll put in 2. And we're going to go, again, we're going back to the reduced. 1, -2, 3, -6. 1, 2, 0, 0, 3, 6, 0, and I have found a positive real 0. Now it's possible that there are 2 more out there. It's possible that 3 and 6 are them. It could be that they're radicals. They could be square root of 5 and then something else. But we're down to quadratic, so we can x squared plus 3 equals 0. And I'm not going to factor this, but I can solve it. Subtract 3 from both sides. X squared equals -3. Take the square root of both sides, and I get x equals plus or minus. Can't take the square root of a negative number. That is imaginary, complex. I square root 3. And the original 0 that we found, -1. Oh, and 2. Sorry. We have found 1 positive, 1 negative, and 2 complex. All right. Example 3. Find the rational zeros. We've got, let's hit it with Descartes' rule of signs first. 1, 2 changes. So 2 or 0. Positive, real zeros. F of negative x. -2x cubed plus 3x squared plus 8x plus 3 gives us 1 change. So 1 negative. Real 0. So we have 1 negative and 2 or no positive ones. Let's go through our P's and Q's. P is plus or minus 1, plus or minus 3. Q plus or minus 1, plus or minus 2. P over Q is plus or minus 1 over 1 is 1, 1 over 2, plus or minus 1/2, plus or minus 3 over 1, 3, plus or minus 3 over 2. All right, so we've got 8 to check. Let's see if we can find the 1 negative. Let's see, we're at 2, 3, -8, 3. 2, 3, -8, 3. And let's try -1. Bring down the 2. -2, 1. -1. -9. 9, 12. Didn't work. All right. Try -2. I'm not going to rewrite. I'm going to just use my eraser. Save a little bit of time here. All right. Putting in -3. See if that works. -3. We've got -6, -3, 9, 1, -3, 0. I have found the 1 negative real 0, and it's down to quadratic. The truth is, it didn't matter if I went after the positive ones or the negative ones, because it's cubic. I just need to find 1, and then I'm down to quadratic. So I found this one. We have 2x squared minus 3x plus 1 equals 0. This factors equals 0. 2x minus 1, x minus 1, and we get final answer x equals negative 3, positive 1/2, positive 1, 1 negative, 2 positive. All right, example 4. To do example 4, I'm actually going to take a look at the lower and upper bound rule first. I want to show you how this works. So the lower and upper bound rule, if I'm testing a possible 0 that is positive, and I do the synthetic division, and the bottom row ends up being, it's not a 0, and the bottom row ends up being all positives. So I'm testing a number, some number 3. It's got to be positive. And it's not a 0, and I end up with positive, 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 then there are no zeros bigger than 3. So even though 3 wasn't a 0, there's no zeros bigger than 3. So I'm not even going to check them. So if 3 is the smallest positive one on my list of possibilities, I'm going to eliminate all the others. Okay? This would be an upper bound. If any of these weren't positives, 0 doesn't count because 0 would be negative, would be neutral. If any of these are negative, then 3 is not an upper bound, and I keep looking. Okay, there's a different rule if 3 is negative, or if the number that I'm checking is negative, say negative 1, and I'm checking this number. This time, for it to be a lower bound this time, would be positive, negative, positive, negative, positive. They have to alternate. As long as the bottom row keeps alternating signs, then there would be no zeros to the left of negative 1 on the number line. There would be no zeros smaller than negative 1. This would be a lower bound. Okay, so we'll keep that in mind as we do example 4. Example 4, let's hit it with Descartes' rule of signs first. 1 change, 2 changes, 2 or 0, positive, real zeros. And now we do f of negative x, negative 10x cubed minus 15x squared plus 16x plus 12. 1 change, 1 negative, real 0. And let's go through our P's and Q's. Okay, so this one has a ton of P's and Q's. P equals plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 12. Q, plus or minus 1, plus or minus 2, plus or minus 5, plus or minus 10. P over Q, has 1 over 1, plus or minus 1, plus or minus 1 over 2, plus or minus 1 over 5, plus or minus 1 over 10. Plus or minus 2 over 1, or 2. Plus or minus 2 over 2 is 1, I already have that. Plus or minus 2 over 5. Plus or minus 2 over 10 is 1/5, I already have that. Plus or minus 3 over 1. 3. Plus or minus 3 over 2. plus or minus 3 over 5, plus or minus 3 over 10. Plus or minus 4 over 1, plus or minus 4 over 2 is 2, already have that, plus or minus 4 over 5, plus or minus 4 over 10 is 2 over 5, we already have that right here, plus or minus 6 over 1, plus or minus 6 over 2 is 3, plus or minus 6 over 5, plus or minus 6 over 10 is 3 over 5, we already have that one, plus or minus 12 over 1, plus or minus 12 over 2 is 6, plus or minus 12 over 5, and plus or minus 12 over 10 is plus or minus 6 over 5. We already have that one. So these are our possible rational zeros. There are 32 numbers to try here. That's a ton. Let's hope that we get lucky finding the negative, or we find some upper bounds and lower bounds that are going to narrow down our search. Okay, so let's check. I'm going to look for the negative first. No, I'm not going to look for the negative first. I just want to show you something. No, I am going to look for the negative first. Let's look for the negative first. 10, negative 15, negative 16, and 12. And the first negative whole number that's easy to work with is negative 1. Bring down the 10. Negative 10, negative 25, positive 25. That's going to be 9, negative 9. And that gives me positive, what do we got here? Positive 3. Okay, not a 0. Let's try negative 2. 10, negative 15. I probably should just erase negative 16, 12. Bring down the 10. Negative 20, negative 35, positive 70. Let's see, that's going to be 60, 54, negative 108, and then negative 90, 96. All right, so it's not negative 2, but what do I notice? Positive, negative, positive, negative. Negative 2 is a lower bound. There are no real negative zeros smaller than negative 2. Negative 3, no. Negative 6, no. Negative 4, no. Negative 12, no. Okay? None of those are possibilities. There's still the fractional possibilities. Negative 1/2, negative 1/5, negative 1/10, negative 2/5, negative 3.5, because that's smaller than negative 2, negative 3/5, negative 3/10, negative 4/5, negative 6/5, negative 12/5. That's going to be, yep, negative 2 and 2/5. So all of those are possibilities, but they're all fractions. I want to keep this as simple as possible. There's still some positive ones out there that we can try to find. So let's look at positive 1 or positive 2 or positive 3. I'm actually going to save a little bit of time here. I'm going to go, because I've tested a bunch, I'm going to check positive 2. Remember, I only have to find one of them, and it gets down to be squared, quadratic. So I know only because I've done this. I probably would have tried, I tried positive 1 first. I'm going to try positive 2 now. 10, negative 15, negative 16, positive 12. Bring down the 10, 20, 5, 10, negative 6, negative 12, 0, and I have found my first 0. So it's now quadratic. 10x squared plus 5x minus 6 equals 0. Now, I'm going to tell you right now it doesn't factor, so we're going to go to the quadratic formula. X equals plus or minus b. I'm sorry. I'm jumping ahead of myself. Negative b plus or minus square root b squared minus 4ac all over 2a. This gives me negative 5 plus or minus square root 25 minus 4 times 10 times negative 6 all over 2 times 10. I'm going to save you the calculations. This comes down to be approximately, after I do out 25 minus 240, that's going to be square root of 265 divided by 20. So negative 5 plus the square root of 265 divided by 20, negative 5 minus the square root of 265 divided by 20. The first one gives me 0.5639, and the second one gives me negative 1.0639. So that means that x equals negative 1.0639 and 0.5639 and positive 2. One negative, two positives. That's example 4. Example 5 is find the zeros again. So let's hit it with Descartes' rule of signs to start off. So 1, 2, 3 changes. So we have 3 or 1, positive, real, 0. F of negative x, negative x cubed minus 5x, 53 x squared minus 103x minus 51. Negative, 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 negative. No changes. 0, no. Negative. Real. Zeros. So that's going to help us with our list. Our list is going to be much smaller now. Half the size. All right. So P, which is the only one I need to look at because my Q is a 1. So P is equal to 1, 3, 17, 51. Remember, I don't need the negative ones. There are no negatives. So let's try first one on the list, 1. So 1, negative 53, 1, negative 53, positive 103, negative 51, 1, 1, negative 52, negative 52, positive 51, positive 51, 0, and we have found our first 0 on the first try. Okay, and it's quadratic. X squared minus 52x plus 51 equals 0, and this actually factors. Equals 0. We get x minus 1, x minus 51, which gives me x equals 1 double root and 51. 1, 2, 3 positive real zeros. There's example 5. Example 6. All right, so example 6, we get this ugly one here. And before I even hit it with Descartes' rule of signs, this is all these fractions in here. Let's see if we can make this function easier to work with. Okay, so f of x can also be written like this. Watch this. 6 over 6x cubed minus 4 over 6x squared plus 3 over 6x minus 2 over 6. All I did was get common denominator for all of these fractions. So f of x can be 1/6 factored out. I can factor out the denominators. 1/6, 6x cubed minus 4x squared plus 3x minus 2. So this is 1/6 times a different function. That other function is g of x equals 6x cubed minus 4x squared plus 3x minus 2. Now, where this new function g of x, where that's 0, it would end up being 0 times 1/6. So that means that g of x and f of x have the exact same zeros. 0 times anything is going to be 0. So wherever g of x is a 0, f of x is also a 0. So I'm going to find the zeros for g of x because it's much easier dealing with whole numbers. Okay, so let's hit this with Descartes' rule of signs. And we've got 1, 2, 3 changes. So we have 3 or 1 positive real zeros. G of negative x equals negative 6x cubed minus 4x squared minus 3x minus 2. We love to see that because there are no negative real zeros. So now when I do my P's and Q's, I only have to worry about the positive ones. All right, P equals 1 or 2. Not plus or minus 1, plus or minus 2, just 1 or 2. Q is 1, 2, 3, 6. P over Q. Half as many possibilities because of Descartes' rule of signs here. 1 over 1, 1 over 2, 1 over 3, 1 over 6, 2 over 1, 2 over 2 is 1, 2 over 3, 2 over 6 is 1/3. Here are my 6 possibilities. These are the only ones that we need to check. Okay, so now I'm going to test positive 1. Because that's the easiest one to start with. We've got 6, negative 4, 3, negative 2. So I test that, pull down the 6. 6, 2, 2, 5, 5, 3. It's not a 0, but what do we see? I see all positives. That means it's an upper bound. 1's not a 0, but neither is 2. I did the synthetic division once, and I eliminated 2 possibilities. That means I'm down to these fractions, right? So instead of wasting your time of checking the 2, 1/2, 1/3, 1/3, 1/6, I'm going to go right to the one that does work. It's 2/3. 6, negative 4, 3, negative 2. And pull down the 6. 2/3 times 6 is 4. 0, 0, 3. 2/3 times 3 is 2, 0. I found 0. 6, this is now x squared, this is cubic, quadratic. We've got 6x squared plus 3 equals 0. Subtract 3, 6x squared equals negative 3. Divide both sides by 6. X squared equals negative 1/2. Square root both sides. Square root both sides, I get x equals plus or minus. It's negative, so it's I over square root 2. And if we rationalize that denominator, you don't need to, I'll be happy with this, but if you rationalize this denominator like your algebra teachers make you do, it's plus or minus I square root 2 over 2. So x is equal to plus or minus I square root 2 over 2 and 2/3 is the other answer. That's example 6. Got some IXL that you want to do and your bookwork. That's it. Thank you very much. Bye.